Nuclear waste. We've got a lot of it, it'll stay dangerous for tens of thousands of years, and we don't really know what to do with it. So why don't we just send it into space and crash it into the sun? Well, first, it's really dangerous to put nuclear waste on a rocket, since rockets have a tendency to occasionally explode while launching, making any nuclear waste-filled exploding rocket into a really big, dirty bomb. But the bigger reason is that it's actually really hard to get to the sun. It might seem like it should be easy since the sun's gravity is always pulling us towards it, but we're also orbiting really fast sideways around the sun so that as we fall towards it, we miss it. In order to crash into the sun, you have to slow down so that you're not going sideways really fast. The Earth and everything on it is moving around the sun at around 30 kilometers per second, so you'd have to accelerate to a speed of 30 kilometers per second backwards away from the Earth in order to stop moving around the sun and do a sun dive. And you have to slow down all the way. With even a little bit of sideways speed, you'll miss the sun and whip around, not crashing. Okay, so a speed of 30 kilometers per second is really fast, but just how fast? Well, from Earth's orbit, you only need to be going 11 kilometers per second faster than the Earth in order to escape from the entire solar system, which means that it's much harder to crash into the sun than to escape it altogether. Let me say that again. It takes less acceleration to get to other stars than it does to get to our own sun. Crazy. But it gets weirder. Because the gravity from an object is stronger the closer you are to it, the smaller your orbit is, the faster your orbital speed. For example, Mercury goes around the sun at a speed 1.5 times faster than the Earth, while Pluto goes only 1/6 as fast. And that means it's actually way harder to crash into the sun from Mercury than from the Earth, even though you're closer, because you'd have to accelerate to a speed of 48 kilometers per second backwards instead of 30. And it's way easier to crash into the sun from Pluto, since you only have to accelerate to a speed of 5 kilometers per second backwards. In fact, if you're trying to crash into the sun just using rockets, it's far more efficient to first go to the outer solar system where your speed is much lower, then do a second burn to counteract that slow orbital speed and allow you to fall directly into the sun. And that's precisely why early mission trajectories for NASA's spacecraft to study the sun proposed going out to Jupiter first, to make it easier to slow down and get to the sun. Ultimately, they decided instead to use repeated flybys of Venus to slow down the probe and save on rocket fuel getting to the sun. But how gravity assists work is a topic for another day. Speaking of which, how long would a day be on the sun? I'd like to thank Audible.com for supporting this video. Audible is a leading provider of audiobooks with over 250,000 works, including fiction, nonfiction, and periodicals. With so many books to choose from, I recommend you check out The Paradox of Choice by Barry Schwartz, about how having more options is not always better, and how to minimize the struggle of making the million choices confronting you every day in your own life, like which book to read next. Just read The Paradox of Choice, and you can do so for free with a free 30-day trial at audible.com/minutephysics.